Totally. Okay, let's go over this review. Which two numbers are going to multiply to make 18 and add together to make 11? In this case, this is positive, both of them are going to be positive. The stuff that multiplies together to make 18, if you get stuck on this, you can make a factor tree to kind of keep it organized. And start with the easiest one. 1 times 18, 2 times 9, 3 times 6, and then we run out of factors. 4 doesn't go into it, 5 doesn't go into it. If you are stuck further beyond that, you can go on the calculator, you can hit the graph, and you can enter like 18 divided by x, and then hit Control, and then the T button. It'll pull up a table. You can scroll through that table and find the whole number values, and that'll give you any factors that you are missing. So that should help out if you get stuck doing something like that. For this one, the ones that multiply to make 18 and add to make 11 are 9 and 2. 9 times 2 makes 18, 9 plus 2 makes 11. What two numbers are going to multiply to make negative 56 and add together to make negative 1? It's key to remember on this one that one of them has to be negative, the other has to be positive. That's how we get such a small number on this one. It's going to be a negative 8 and a positive 7. If you had written this as a positive 7 and a negative 8, that's still correct. The order of the numbers doesn't matter. The only thing that matters is making sure you have the correct numbers with the correct signs. Now on 3, 4, 5, and 6, I put this one in here on purpose like this. All of the answers to 3, 4, 5, and 6 are 6 and 4 in some form. Okay? The key element to this one is understanding where those negative signs, where those positive signs, where they need to go. So what two numbers multiply to make 24 and add to make 10? It's a positive 6, a positive 4. What two numbers multiply to make 24, add to make negative 10? It's going to be a negative 6 and a negative 4. What two numbers multiply to make negative 24, add together to make 2? On this one, it's a negative, so only one of them needs to be negative. It's going to be the negative 4 because we get a positive number when we add them together. The one that's further from 0 needs to be positive. Same thing down here on number 6. Multiply to make negative 24, add to make negative 2. It's going to be negative 6 and positive 4. That way, when we combine those, we get that negative 2 that we need. What two numbers multiply to make a negative 24, add to make 5? This is just thrown back in to make you understand for sure that there will be different factors that multiply to make the same thing. And you can tell what you're supposed to get by the number that's out there on the outside. I know the difference between them has to be 5. So this is going to be a positive 8 and a negative 3. Okay, 8 times negative 3 will give me negative 24. 8 plus negative 3 will give me 5. Down at the bottom, all of a sudden with 8 and 9 and then the stuff at the top of the next page, it seems like we're doing something completely different. We're really not. What's going to multiply together to make 12 and add together to give us a negative 8? The numbers that work for that are a negative 6 and a negative 2. Because we have the x squared out front, we're not just looking for those two numbers. We also have to figure out what's going to multiply together to give us x squared, but it's just x and x. On the papers that we had, they kept using different variables up front. For this review and the test, I didn't. Everything's just x. On the factors on this next one, it's the same kind of thing, but it's a positive 8 in the middle that it needs to add together to make. This is still going to be 6 and 2, but they're both going to be positive. And then when we put together the rest of our factors, it's just x times x makes x squared. When we flip this over to the back, we've got x squared plus x minus 12. One has to be negative, and the number that's here is actually a 1. All right? If there's ever a number that's not written in on a variable that's there, that number is always an invisible 1. So this is going to be x plus 4 multiplied by x minus 3. All right? We didn't spend a lot of time like multiplying this stuff together because it's not a real effective way to work quadratics and to deal with quadratics. We might do that if we have some time to come back to it second semester, but it's not something necessarily that you have to apply in your day-to-day life. It's easier to look at it as the factors. On the factor on this next one, multiplies together to make 12, adds together to make 7. That's going to be x plus 4 and then x plus 3. And then down here, again, we have different factors for 12, and this middle number is going to decide which ones you use. In this case, it's x plus 6 and x plus 2. When you get to number 13, this is one like we've done before. A lot of people have been kind of forgetting what we did when we did these. It's fencing. When you fence things in, you want to always have that maximum area on the inside, unless you have a special size to fit. In this case, we're dealing with a rectangle here. This side is x. Now the length and the width, we only have to deal with half of the amount of fencing. So half of that 200 is just going to be 100. This is x, this is 100 minus x. So I've got my length, I've got my width. My length is x, my width is 100 minus x. And then I'm going to find my area, because it's asking to find my maximum area. All right? So on the length, if this is 10, my width is going to be 90. All right? That would be, on my rectangle, 10 feet up, 90 feet across, 10 feet down, 90 feet back across. It adds up to 200, but I only need 2 of the sides to find the area. If it's 10 and 90, it's 900. If we go 20 and 80, that's 1600, so we're still getting a bigger area. We keep going. 30 and 70 is 2100, still a bigger area. We keep going. 40 and 60, 2400, it's still bigger. We keep going. 50 and 50, it's 2500. Now, if we go and continue on in this same pattern, we're going to go up to 60, but the other one will go down to 40, which is exactly the same as the 40-60. It's just rotated. So it won't make a difference in our area.
Let's say 2,100.
2,100 here, 2,400 here, 2,500 here. So this 2,500 is going to be the peak. It's the highest number we can hit. It's going to be our maximum area. That's 2,500 square feet. The side length on that is going to be 50. Now, if you remember this, if you can remember from the paper that we worked on for this one, the largest area always comes when our fence is a square. So if you can remember that the biggest one is just going to be dividing the side up, or dividing the length up evenly between the 4 sides, unless it asks for a table, you don't have to make the table. You can just say, oh yeah, I know what the peak is going to be. The peak's going to be when it's a square. Down here on the bottom, the Netflix one, this one was actually more complicated than I thought, but that's okay. If Netflix charges $12 a month, they go $12 a month. They have 50,000 subscribers. I'm just going to put that as 50K. They're going to raise prices. They expect to lose 1,000 subscribers for every 50 cents. That's minus 1,000x. Okay, that K is not a variable. Don't think of it as a variable. And then we've got 12 plus 50 cents x. Every 50 cents they raise that price, they're going to lose 1,000 subscribers. But because it's more expensive, it should make up for it. Okay? Shh. I'm making this video so that all the classes can see it, so please make sure you're staying quiet. Thank you. I didn't want to do every 50 cents on this because I didn't want to take the time. So I just went by dollar amounts to go through pretty quickly. If it's $12 and we have 50,000 people, that's going to be 600,000 a month. 13 would put us down to 48. Because remember, we are losing 1,000 people for every 50 cents. So it's 2,000 people for every dollar that we put it up. 14 is going to put us at 46. 15 is going to put us at 44. 16 puts us at 42. 17 puts us down to 40. So when we check the prices on these, or how much we're making, it's 624, 644, 660, 672, 680. We can tell that we're supposed to keep going because the money that we're making keeps on increasing. So I come over here, I go to 18. At 18, I've got 38 and it's 684. So I'm still increasing at this point. I keep going. At 19, it's 36. And I've got 684 again. Now, if you're doing one of these tables and you end up with a repeated value like that when it had been increasing all the way up to that point, we know that we've hit our peak, but it's not either one of these. It's going to be in the middle of that. The only reason we get to the same number is if we have gone up past it and then we come back down to it. So we're going to go dead center of these, which is going to be $18.50. When we're at $18.50, we get 684.5 because we have 37,000 subscribers. So this is 684.5, but it's really, that's still thousands. That's $684,500 every month. Now Netflix has a lot more actual subscribers than that, but that's probably not far off of what they're taking in a month. And then, you separate the profit from your expenses and all that kind of stuff. Keep this stuff in mind. If you get stuck on it, you don't know how to do it, stop by for tutorials in the morning, get it figured out. The test is tomorrow.